Hey there, science fans. Today we're going to talk about something super cool, linear expansion. What is it? Well, it's how things get bigger when they heat up. You know how a balloon expands when you blow air into it? Linear expansion is similar, but instead of air, it's heat that makes things expand. Imagine you have a metal rod. When you heat it up, the rod gets a little bit longer. That's linear expansion in action. We can even measure it with a simple formula, dl equals L dt. Don't let the Greek letters scare you. It just means the change in length, dl, equals the original length, L, times a special number called the coefficient of linear expansion, alpha, times the change in temperature, dt. This expansion happens because heat makes the molecules in the rod move faster and spread out. It's like giving them all a little extra wiggle room. Linear expansion happens all around us, and it's used in some pretty amazing ways. So buckle up, because we're going to explore some mind-blowing applications of this scientific wonder. Have you ever noticed those small gaps between railroad tracks? Ever wondered why they're there? You guessed it, linear expansion. On a scorching summer day, the metal tracks heat up and expand, getting a little bit longer. Without those gaps, the expanding tracks would push against each other, causing them to buckle and bend. That would be disastrous for trains trying to speed along. Those gaps, called expansion joints, allow the tracks to expand safely without causing any derailments. Engineers carefully calculate the size of these gaps based on the type of metal used and the expected temperature changes in the area. It's a delicate balance, but it's crucial for keeping our trains running smoothly and safely. So next time you're waiting for a train, take a look at the tracks and appreciate the simple but brilliant solution of expansion joints, a testament to the power of linear expansion, to our understanding of linear expansion. Section 4. Everyday marvels of linear expansion. Linear expansion isn't just for big things like bridges and railroads, it's all around us in our everyday lives. Ever struggled to open a tightly sealed jar? Try running hot water over the lid for a few seconds. The heat causes the metal lid to expand slightly, making it easier to twist open. Another cool example is the Hubble thermometer. You know, the ones filled with that shiny silver liquid. That's mercury, and it expands when heated. As the temperature rises, the mercury expands and rises up the narrow tube, giving us an accurate reading of the temperature. Thermostats, those little devices that regulate heating and cooling in our homes, also rely on linear expansion. They use bimetallic strips, which are made of two different metals that expand at different rates when heated. This difference in expansion causes the strip to bend, which acts as a switch, turning the heating or cooling system on or off as needed. From opening stubborn jars to keeping our homes comfortable, linear expansion plays a surprising role in our daily routines. Section 5. Linear expansion in technology and beyond. Linear expansion isn't just a scientific curiosity, it plays a crucial role in advanced technologies too. In the world of tiny electronics, where components are measured in nanometers, even the slightest expansion can make a big difference. Engineers designing computer chips, smartphones, and other gadgets need to carefully consider the expansion and contraction of different materials to ensure that these devices function reliably under various temperature conditions. In the realm of scientific research, instruments like scanning electron microscopes, which allow us to see objects at the atomic level, require precise temperature control to function correctly. Even the slightest temperature fluctuation can cause components to expand or contract, throwing off measurements and affecting the accuracy of results. Linear expansion is also essential in manufacturing processes like glass making, where controlling the expansion and contraction of glass during heating and cooling is crucial for creating strong, flawless products. From the bridges we drive onto the smartphones in our pockets, linear expansion is a fundamental principle that shapes our world and enables countless technological advancements. So keep your eyes peeled. You'll be amazed at how often this simple yet powerful phenomenon pops up in unexpected places.